Okay, good afternoon to one and all present here. Welcome to the session 2 of the IEEE sponsored 1 week faculty development program on recent tools for integration of smart system. Speaker of this session are Mr. Abhimanyu Chavan and Mr. Maneesh Yadav, who are associated with Government Body India Meteorological Department. So before hand over the session, I want to give brief introduction of our speakers. So first speaker, Mr. Abhimanyu Chavan. Currently, he is working as a senior research manager, Geospatial World Noida. He handling the Department of National Geospatial Agencies, which looks into the Earth observation activities of national agencies throughout the globe. I welcome sir to the second session.
Thank you.
Then second speaker is Mr. Maneesh Yadav, who is a remote sensing and GIS expert, Indian Council of Agriculture Research, Central Agroforestry Research Institute, Jhansi, UP. He worked as a senior research fellow in Indian Council of Agriculture and Research and Indian Institute of Soil and Water Conservation. He also associated as project fellow in Haryana Space Application Center for study of waterlogging and flash flood zone of Gurgaon, Haryana. So without any further delay, I'll hand over the session to Mr. Abhimanyu and Mr. Manish. Over to you, sir.
Thank you so much for the introduction. So without delay, we'll start. Actually, as we have seen earlier in the presentations, all the data sets we talked about. So I just, because people are more interested into just getting the data because they want to access the data and just do the research and other R&D works. So I just showcased the three main actually repository where we can access all the available global data as open source from the 10 meters to the 30 meters in a spatial resolution and 30 meter as a digital elevation models also. So first, I would like to show the Indian ISRO's open source platform. So this is our first repository, which is from the Indian satellite constellation sector. So this is geospatial platform of ISRO, and all the data sets, their applications, and other open source GIS platform, everything being developed and hosted here on this one platform called as Bhuvan. So when I was associated with them, I was working with this department closely regarding all the satellite activities and the data generation. So if you go to the website, so you will see this section, Open Data Archive. Okay. So what you have to do is first, before going to this, I would suggest you first register yourself here and create your account, because while downloading it will ask your subscription account, like a registration account. So then only you can download the data. So as you go into this, so this you will see this a new page where in left side here you can see the satellite category, themes, products, and other things. So basically we are interested in satellite data, so we'll remain here and then we'll select the sensors. So we have what are the sense data free of cost. So, in earlier presentations in morning session, somebody asked me about the hyperspectral. So this HISIS data was not available earlier. So this time they have released this HISIS data. This is around kind of 64 bands. Yeah. So now people can have access to this data also. This is hyperspectral data of 64 bands, but this is coarse resolution. So if it is useful, so they can use it, 500 meter spatial resolutions. So yeah, so it is available from the Indian sector. So one data is AVIFS. This is very coarse, very less used because it has a 56 kilometer of resolutions. One is the Cartoset one. So this is the most usable data as a 3D data set. So in Cartoset, you have to select this Cartodem version 3. Like there are some versions. Okay, so this is the latest version. So version means every year some of, while processing the data, we find a lot of like some of the areas where the data is not coming correct, or some of the areas required rectifications. So those areas we improve every year, and every year we release some kind of versions. So this is the latest version, version 3. And instead of going to all these things, the simplest way is tiles. You go to the tiles, select start, and yeah, up now you can find out your place wherever you want to download one. Just So these selections you can do, either you can just pan like this, and these many data sets you selected this much area if your interest area, then you can go to next, and yeah, now you can see the data sets selected here. Yeah, this kind of, and same data if you click it will automatically download here. So this is 5.8 MB data sets, and this later on you can open it, it is into the TIFF format, and you can access this data. This is the 3D data, uh, and like this only you can select this list 3. This is 30-meter 4-band data set, where you can have the our most demanding data sets. So the same way this data also you have to use, correct, and you have to select the areas, then you have to click next, and you can preview your data sets. See, so these are FCC actually combination in preview, just to better understand the data. So like whatever the data area you are feeling like, you can download just putting the press button, but for that you have to be logged in here, like here login option is there. So here please, like I logged in. So this is one source. Here you can get the raw data, open source data, and then you can uh, implement your tools. You can implement your algorithms there, you can use in different softwares and extract the information accordingly. And those who are research scholars and interested in very latest, because this data is old data basically. So those who are interested in recent data, very new data sets, or high resolution data sets, which is of least 4 sensor. So least 4 sensor is 5 meter having resolution and very nice data. So they can write directly to the NRSC head, National Data Center, Hyderabad, and they can provide, meantime they can provide their data based on your research area free of cost. Otherwise it is paid data. Okay, so this is one portal. Second one is the Earth Explorer from the NASA USGS. Okay, so whatever the satellites they have in open source is most popular everywhere being used now is the Landsat series. So here you can uh, put your search area, KML file also you can upload here, or anything, path, row, whatever, because it has a lot of options. Then you can go to here dataset, you can select your satellite EU1 Earth observation 1, then here this Landsat, here the Landsat are there, so you can select the Landsat whatever the data you want, and the results you can show that see the data and download. Here they have provided the Astra also, and last last year ISRO have collaborated, signed MOU with them to provide the data of least 3 sensor and EV Indian satellite sensors for US region. So like now we will be soon hosting their Landsat data in our portal, and as they have already hosted their data sets, so Sentinel also you can get it here. For exclusive Sentinel data sets, ESA is having their own open source platform named as Copernicus. And in Copernicus, if you go, this is the Open Hub. Here in Open Hub, you can go and yeah, here also everywhere you have to create your account. It may take, in ISRO it won't take much time, but these platforms required verification, something, some little bit of the time they take, 1 day 2 day, but yeah, you can create the profile because procedures are little bit lengthier than other one. So here also you have to select, sort by like sensing date, tile, sensing period, order, that missions, what is the data you require for Sentinel-1, Sentinel-2, Sentinel. These are the 3 open source satellites they have released for public domain. So any data sets you can select the date, and yeah, you can just go, and that data will reflect, and you can simply download everywhere the same procedures, only different structure they have built for. So these are the basically three open source hubs from where all the people globally they are accessing data. And this one set of data, this is the meteorological data portal, and this is exclusive data only available nowhere else. This is developed in collaboration with the ISRO and India Meteorological Department for hosting IMD's Meteorological satellites. There are 2 operational satellites, that is INSET 3D and 3DR, where imager and sounders are installed as a sensor. So instead 3D sounder is stopped working. In extension of that, we launched the insert 3DR where the sounder and imager both are working. And here from the stats, you can select the data from which you want, but the data is not downloadable. This is there you can access the products only. So they have so many products, 3D imager, like here you can select, just a minute. Yeah, so here you can select, these are the actually available bands on the sensor. So anything you can select and see like what is happening, and this data, whatever the data you are seeing on the on your page, in on your screen currently, this is the very real data, like it is just maybe half an hour late. This is 2 ist, so it's very recent data. So here data every half hourly they are updating the data here. So it's like huge. So backend mein the database is running parallelly, and when the cyclone or any weather big event is happening, so that time we every 4 minutes 30 seconds you will get a data here in real time. That is the fastest data receiving platform we can see. So all the monitoring activities of weather systems we are doing with this platform. So you people can come and see, a lot of products are there for you to see. So that's it as open source data, and I hope you people uh, um, understood like what I'm wanted to show. Like it's like later on you can go and explore. There are a lot of things available as open source to do R&Ds. So from my side, that's it. Okay. So like time is constrained, so could not show much of that. So later on someday we can proceed with that thing. So I think next is Manish. So he is quite uh, having good expertise in data processing on Google Earth Engine. So you must be enjoying his session. Like it's open source, fully open source hub, and whatever your requirement, how we can access without software, without going to down, like without downloading data, everything he is going to display. Like whatever your earlier questions, he will clarify. So Manish, over to you.
Okay, thank you, Vinay. And thank you to the panel for this nice arrangement of this introduction of remote sensing. And now I am Maneesh Yadav, and I am working as a geospatial expert in ICR, Indian Council of Agriculture Research. And so after the introduction of remote sensing, I will introduce about how I use remote sensing techniques using Google Earth Engine platform. So I will share my presentation. So, so now my presentation, as you can see my presentation. No?
Yes, yes, it's with you.
Okay. Okay, sir. So basically, due to the lack of timing, so I will short introduce about my presentation, and then we will uh, use our timing in hands-on training. So yes, basically Google Earth Engine is a cloud-based platform for use the process all global level data base of remote sensing data, uh, which is used to analysis of a drought, disaster, diseases regarding data analysis. And Google Earth Engine is based on mainly three components based on a data catalog, which used a huge remote sensing data to process. And these are the in this picture we can see that there is a lot of servers of Google based servers which is used remote sensing data. And our mainly focus is which Google Earth Engine code editor. Basically, this code editor is used to analysis of remote sensing data based on Python or JavaScript based algorithms. So for initially, we need to sign up in Google Earth Engine, and this is the process. This is the basic understanding of registering in Google Earth Engine account. So we need some Gmail account, and then we can sign it, and we can use all the properties of Google Earth Engine. Uh, in Google Earth Engine data catalog, we used various various types of remote sensing data such as Landsat, Sentinel, MODIS, vector data such as Tiger, WDPA, or HydroSat, etc., and various types of terrain and climate data. And these are some common use in Google Earth Engine platform. We can use petabytes of imagery daily, more than 4,000 imagery per day download or stored in Google Earth Engine clouds, and we can embed with different types of apps and share with our codes, import, export with a raster and vector dataset. And basically, Google Earth is not available for cartography and heavy vector operations such as geoprocessing, etc. So these are some key points. Google Earth Engine is a very powerful tool for analyzing remote sensing imagery. Google Earth Engine has a lot of data which is used for various types of remote sensing processing. And why we use a Google Earth Engine? Basically, Google Earth Engine enables user to compute lots of data with use of different temporal resolutions and different types of such as multispectral or hyperspectral or DAM-based data. So this is an example of Indonesia forest changes in from 2000 to 2012, and you can visualize using a global forest watch. And also some regions of is there, free cloud processing with built-in functions, massive online public data archive is there. You can upload your own data in Google Earth Engine, and you can take care of your version control of codes, and very flexible with the APIs, different types of APIs, which is based on Python and JavaScript. This is the basic user interface of Google Earth Engine code editor, which is used to process your code and to command remote sensing, various types of remote sensing data. In this Google Earth Engine user interface, we used some section, yes, such as in this section, we used a script menu. This menu is stored your script and your helping script. In this panel, we can light up your script. And this map section is to visualize your results. And this section is used to your inspect or your console. It's just visualize your error or some print functions and visualize charts. So these are, I will provide the more detail in hands-on training about this user interface. And these are the many data types which is used to process remote sensing data, such as image collections and geometry and feature collection, filter and classifications. In image, we used a particular image to process remote sensing data, and in image collection we process various types of image collections, and then aggregate these using a filter. And geometry feature collection is a vector-based operations, and this is used to bound your area and mark your area of interest. And this filter and filter is just a filter of your image collection or feature collection using this particular conditions such as bounds, distance, and metadata, etc. And various types of classification you can use to process in Google Earth Engine platforms such as card, random forest, and support vector machines, etc. So now we are going directly in a hands-on training program. So we are going to share my Google Earth Engine code editor. This is my code editor, and where how to going in code editor. So okay, so basically we search a Google Earth Engine. So just search Google Earth Engine and going to here and just sign up your Google account using your Gmail ID. Then you can sign up with this simple operation. This is a very simple operation to sign up in this ID and continue. I am already signed, so I directly continue with my Google Earth Engine and try the code editor. So I'm going to try code editor. Continue. So this is my code editor. In this code editor, I have some sections such as this is a code editor section. You can create your own script in this section, and this section is used for store your script. And this panel is used to search remote sensing data. And this is your this section you can use to map your results. And by these tools you can draw various types of geometries and feature collection, etc. So now I am starting to create your own geometry. So for create geometry, you can click on these tools. So I create this is a polygon tools to create and search your area of interest. For example, in India, I have working with in New Delhi. So I create some geometry like that. So this is a geometry I have created in a Google Earth Engine, and you say there is an import section. Then this section has when I create a geometry, then it's overload in this section. So you can also see there is some vertices is also available, which I generated from this geometry. So this is some basics of the geometry creation. Then I can also rename like ROI. It's the region of interest. And now I am searching our remote sensing data. For example, I searching a Sentinel-2 data and import in import section. So you can see here there is a image collection name is there, and you can rename it as Sentinel-2 data. Sentinel data, and so now we have created two variables. Such one is ROI is the geometry, and second is Sentinel data. So you can see there is an option to search various types of remote sensing data. You can share Sentinel-2 data, Landsat data. These these are the open source data. You can available with various USGS or ESA based, but you can directly import using a search in Google Earth Engine. So there is no time to waste, and you can import and process within a minute. And now, if you are familiar with the JavaScript based library, JavaScript programming, then you can now what is a variable. For example, I create a variable. For example, database, and import this Sentinel data in this variable. So you can see here it's stored in database variable, and you can also visualize by use of map.add layer and give their variable name, and you can run with run command, and then if you click on run command, then it's visualized in this map section. So it's taking some time. So let's wait that. So you can see here it's a load remote sensing or Sentinel-2 based remote sensing data in this map. It's taking some time to, because there is only availability of you need to availability of best internet, and we don't care about your local system. It might means your PC, because it's already working on Google server, Google Cloud server. So we don't need a much powerful system to process remote sensing data. We just need a better internet. And also, if you see here, a black imagery is there, but there is no information about what is that's just not valuable. So we use this. This is a layer manager. You can see there is a lots of if you add any layer in using a map.add layer, then you can see it's import a layer. So you can visualize by using of this visualization parameters, and you can visualize as a FCC using a band combination band changes, such as band 8 is for NIR, band 4 is band 5 is for red, and band 4 is for red. And you also need to histogram stretch using these tools, and then apply. So now you can see your imagery in fast color composite mode. It's taking again some time. Now just stretching with this method, and you can now visualize your imagery in FCC mode for Delhi region. So this is a very simple task to how to access in very less time. You can access a lot of imagery of your area, sir. So it take time because it's a load to for whole world. So now we can define your area is as per your region. So if you want to define your imagery with your region, you can bound. You can use filter bound and give the region ROI. You can now this using this command, you can filter your satellite imagery as per your area, but as per your geometry. You have created your own geometry here. So just which satellite imagery which is found with this geometry, it's only shows on that imagery. So now you can just run and filter dot bounds. Okay. Okay. So that's it's a variable, not a constant. So now it's working. It will be working. So again, now it shows just an imagery which is bound with this geometry. So there is no need to time to wait to load your imagery. It's working with very fast. So now we can again visualize in FCC, changing band combinations there, B8, B4, and sorry, B4 here and B5 here. So now just stretching it. I am stretching. Stretching is just used for remove outlier information of image. It's just called histogram stretch, histogram equalization. These are some methods. That's all. So this is some method to visualize your imagery, and in that map.add data, I import already visualization parameter here. So you can use this visualization parameter, and you can put here and give the layer name. It's a sentinel data. So it's directly So you can see here just 2 lines of codes. You can visualize your code with very simple steps, and no need to download and processing it's these data in your system. And you can now don't need to download any software which is very commercially software which is very huge cost. And so you can now here so now I have some prepared codes here. And so for example,
Sir, one doubt while drawing the polygon, I'm not able
yes,
to draw.
okay,
So can you please allow me?
okay. So for drawing a polygon, just open your FCC. This is available. Sorry, your user interface is open, na? Google Earth Engine.
Yes, sir, it's open.
Then you click on this
Polygon.
geometry
Yes, sir, I clicked
polygon
on
button.
that. I clicked
Then
on that.
then click by from here and close it.
Okay.
Same point.
Okay.
Start and end point is always same for a polygon.
Okay, sir, thanks.
Okay. So now we are going some up my some compilation is there for code. We are going with there. That's a lot of code is there. For basic understanding of JavaScript, I have some code is there. I will copy my this code and I will introduce one by one. So this is the console. This is used for a print your any argument or any result. So for example, I have some basic code. This is just uncommented. And now for hello, yes. So for print, just for basic understanding of JavaScript code, so we used some sample here. So just for print, you can use hello world and then click on run. It's print a hello world in console. And similarly, if you want to print some strings, then you can uncomment out this. And it's some string you can print by using or single quote or double quote. So and it's now I am running and print is there. So uncommented it. So just run. So it's a print some string function, string based on some variable and constant. And you can use instead single quote instead of double quote. And for numbering, you can print also number by without use of any single quote or double quote. You can print as well as from using a print function. So again, I print and then my print function is there and it's printed by interpreter. And similarly, we can print yeah, this list function, list variable using this comma, and this is a print variable, and this is a list variable. You can print from using run, then it's so as a variable, as a list variable. And list of strings is there. So and also you can comment or uncomment using a control slash. You can use a comment, and directly if you manually you can use a double slash for making a comment. So using a variable my strings list and then print. It's also print similar type of above number list of numbers, my list of strings. And it's a dictionary, and you can print by using of this comma, and print by it's a pair of a key and pair. It's a combination of key of pair. You can use this dictionary. Dictionary is very important for various creation various function and data types. So that's very important. And you can print your dictionary by using this. It's both where your value and key is there. Right? And dictionary can be stored as a number, as a string, and also as a list. In another function, there is a some. It's also similarly you can extract your static example of similar types of dictionary. You can extract particular value by using its key value, and it's also same. And then now function, and you can create also function using a JavaScript. In JavaScript, we install in this console. You can use this method to create a function. So this all the basic understanding of JavaScript, some symbols we can use in Google Earth Engine. And now we are going to with how to add a visualization, add and visualization of image. So is basically I have already described that thing, but again I have shown some. So again I paste here all the code and commented, and one by one I will introduce all the things. So basically, this is a variable which hold all the image collection which is based on a length set, and this is the ID we can use search. We can use this ID we can search via search section. So for load this length set data, we can also use this search, and it's this ID we can use from here, and we can find out where this for click on this. Then we can find out a collection in snip. It's the ID of particular imagery. So you can directly import from here or can be right here. So you can use this method as well as this method. Or you can use by filter. This filter method is used filter various types of filter we can use in this console, such as filter date, filter bounds. Filter date is used for a filter according to date. If you want to search engine search data in between date range of 2012 and 2015, so you can use as filter date and enter um, start date and end date. These are the combination of start date and end date. So you can search satellite imagery in between of these date, and you can bound using ROI already. We have already a geometry, so you can bound with all the satellite imagery using this method, and you particular search this particular imagery, and then finally you can convert this imagery in band composite using this median method. It's convert your image collection in image particular image, because if you work with the image collection, you have no, you can't working with the particular for imagery. So need to convert this image using this median function. It's the median of all the image collection and used with this map function. So for visualization, now we need to visualization. You can visualize from directly right here, and you can visualize with this import section. So this is the just to visualize. If you want to just visualize your imagery in fast color composition, you can put the bands and combination of this five color composition. Basically, V5 is a when red is band, and V4 is a red band, and V3 is a green band. So you can use this all as a. I think this is used for 8 for fast color composition, and this for 5. Band 5 is for red band, and this is green band. So this is the band combination of fast color composition, and then we can stretch by using of this method, using minimum to maximum, and go for gamma. Gamma is just a visualization method in this import section. Similarly, if you want to visualize in true color composition, then you can use this method, and you can add in map layer section. So finally, I have some this, and and this is also uncommitted, and then I run. So now you can visualize your imagery in true color composition. Visual there is available of this visualization parameter. So this is ROI based image selection of Landsat imagery. Similarly, if you want to fast color composition, if you want to see fast color composition, you can unvisualize and uncommentate this line of code and click on run. And you can also see there is a fast color composition and it's not perfectly. So, okay, it's Landsat based, na? So here 5, 4, 3. In basically in Landsat, band combination for file composition is V4, V5, V4, V3. Then enter. So it's a true color composition, it's a file color composition. So you can visualize a file color composition imagery, and in red color in file color FCC, we can say it's a vegetation. And you can also change a satellite base map from here. Just click on this. It's a map based, it's a satellite imagery based. And you can see here water body in blue color. These are the satellite imagery which I import from Google Cloud Server. And blue color is indicated as a water body, and in red color is indicated as a your vegetation area. And these are the some agricultural land is there, and city area is you can see in this is a city area indicated as a cyan color or something different. So there's a visualization. And similarly, if you in next code, there is nothing important. You can also set your map as a center object. So using this simple command, you can use you can center your map using according to your ROI or geometry. So use this function map.center object, and you can center your map as per your geometry. So for example, if you now if your map is anywhere is there, and now you visualize using run command, then it's the center on a map. So it's just a function to center map. In second code function is there, and secondly I have in image data. Image data is also I have done this image data. This is the same as I have upload add an image in from an select an image collection, and this is just a visualization parameter. Then this is just a map dot add layer. It's already discussed previously previous section. And how find which are the bands is there available in this. So this is very important function. And print band names, image.band names for if image is just a variable to store a particular image, and image.band names to use for visualize band names in console section. To print this, we can see there is a 12 bands is available in this image, and which is named by B1 to B11 or BQA. BQA just non-usual bands, and there is 11 bands is used for our studies. So it's used for the bands information, and similarly we can use another function image.select.v3.projection to identify which band has which projection, you can use this particular function. And similarly, when, for example, in band 3 projection have this EPSG projection, which means it's a has a particular projection is this way. Every band can be have a same resolution, same projection, or it can be different projection. And similarly, if this is not I am discussing about a nominal scale and projection. Yes, if you want to search all the metadata of a satellite imagery, then you can use the image.property names to identify what is the metadata of particular image. So you can run by that, and you can find out how many properties is available for that imagery. So this is band information, this is projection information. Number 3 is metadata property. So there is a lot of metadata, such as data acquired is there, when this imagery is acquired, what is the cloud percentage available is there, such as cloud coverage, how much cloud cover is available for this imagery. So you can search various types of or filter according to this metadata. And you can also search what is the cloud cover of this imagery is here. For example, if you want to search, if you want to filter as per, if you want to get the property names with the cloud cover, then you can find how much is cloud is available in this satellite imagery. So we can see there is a 2.1% of total image area is cloud cover. So where is cloud is available in this imagery? So you can search here. Is there any imageries? There is some clouds available. That's the point of, that's some clouds patches is there. So you can say total area of this imagery 2.1% is cloud cover. So that's some metadata information of a particular imagery. And some mathematical, for example, if you want to see how to visualize image as NDVI, so I have this code is very useful for NDVI. If you want to calculate NDVI, for example, I have 2 types of imagery with a particular ROI polygon. So I just want to comment all of them. There is 2 imagery available for 2000 for the year of 2000 and 2007, and I have filtered with all year of 2014, 1st January to 31 December 2014 for 2014, and image 2017 I have used as landscape imagery, and filter date in filter date start date is 1 January 2017, and it is 31/12/2017, and also filtered by bounds and median. And in last, I have used a clip.roi. It is used to clip particular shape. For example, map.add layer 7. And this is the imagery, and you can see here it's a cut according to geometry. This is a geometry part, and imagery also cut according to geometry particular. So it's happening when you convert your image collection to image by using this median function. Then you can use a clip function to clip as per ROI your image. So you can see here, this is an imagery, and as per you can create your own visualization parameter. For example, it says set data, and we can visualize in fast color composition and stretching, and then approve. So yeah, this is the imagery, and some gamma points is available. So it's a it's a clip according to your imagery geometry. So you can also use a clip function to clip your area as per your region of interest. So I have loaded to image for 2014. I have loaded image for 2017. Now we want to create some NDVI. NDVI for this is the easiest way of NDVI creation. Just use this normal difference based command to use your band combination. Basically, NDVI is just a combination, just a formula of by using a NIR or red band. So V4 is a NIR band and V3 is a red band. So that's a function to create an NDVI for year 2014, and that's a formula. That's a command for 2017 for NDVI creation. And for that, I have this icon for this is just that's all. And now I want to visualize my NDVI for 2014 in map section. So just click on run. So now you can visualize your NDVI for 2014, and in it's you can see here there is a 3 palettes for visualization of your NDVI. It says it's in this satellite based imagery. You can see green color is indicated as a ice healthy vegetation. For example, this in NDVI section, there is some green area is a healthy vegetation near Chandigarh or some Himalaya region, and yellow section, yellow color is indicated as a farm area, agriculture area, and a green color is here. Green color here, you can see here some healthy vegetation is there. So it's visualized as a green color, and its value near to 1. And this is a method of to indicate a visual NDVI pattern. And for this is a we have used for NDVI for 2014, and also we can use the same values for 2017. So here we can change and using we can find out what is the changes of NDVI for different year. For 2014 is there. And it's the for 17, and it's for 14. So we can also calculate the difference between this NDVI using a difference subtract method. 2014 NDVI 2014 dot subtract using NDVI 2017. Then we can find out what is the difference between 2 years of these NDVI. So also we have add a difference in map.add layer. So now I will. So this is the NDVI, and this is the difference. So where we can identify what is the difference between NDVI in this section. This is indicated by using of this black color. There is a high changes is there, and then there is otherwise there is no changes. This is the one method of NDVI calculation, and another method is also available for calculating NDVI for using this. This is also create a expression using mathematical expression using this image band select, and image using subtract and divide arithmetic rules apply in this imagery band, and also create using this expression method we also create this. This is another method of to create an expression, create a formula, then put as a dictionary in this using this imagery and create a dictionary. This for create and this type of expression, we need to use a dictionary method. So these are all the method to create a Google Earth engine, and this is the simplest way of create a NDVI imagery. So this is the example of create a NDVI. So now I am going to visualize what is a time series chart which is used to create using imagery. So
So do we have some inbuilt function where we don't have to do the coding, or the coding is a mandatory requirement, prerequisite for using a Google Earth engine?
basically, in Google Earth Engine, we need to it's a platform to use all of imagery. It's a data collection, so we need to use some codes. Some basic codes is needs, which is based on a JavaScript as well as with Python.
So they're easily available that we'll just take it and as per our data, it will process it, or because.
Yes, you can access various types of scripts in it's open source and you can easily get a Google Earth Engine and also various types of scripts in GitHubs. It has a community of Google Earth Engine script which have available all types of scripts for process any types of data. So its name is Awesome Google Earth Engine. It's a community in GitHub that will be provide all the types of scripts which is used for your specific commands.
Okay.
Yes.
Thank you. Thanks.
So for create a Google in NDVI chart. Sorry, run. In this example, we are showing how to create a time series chart of NDVI. So basically, this is the code of NDVI to create NDVI. And then finally, one line is need here for just print UI.chart series and give the NDVI variable which I have created in there green with the NDVI.select and ROI. This is the sample points which I need to create a Google time series chart of this area for NDVI. So I just used this as a in ROI as a sample points and give the Google Earth in NDVI with brand name. Actually, this is the same process which I have shown in previous slide to create a NDVI imagery. And ROI is the another arguments for that. So ROI is already created by using of geometry functions, and so it's a time series chart of particular area for throughout of the year. In February, the NDVI is very low, and in June, July, August, it's very high because there is some aspect of rainy season. And in rainy season, vegetation health status is very high. So its value is also very high. NDVI value is high, also very high. So this is the basic function of create of NDVI time series. And similarly, this is also for I have created for your center object geometry. This is also I have create a NDVI imagery, and for a short time series, time series chart is there, and I export in another level. This is a date wise short time NDVI time series data. So where we can find out where is the NDVI status is down and where is high. So in classification, for classification, we need to create some sample points using geometry tools for classification of particular satellite imagery. So, for example, I this is some flow chart. You can say steps of creative Google classification using a Google Earth engine. Initially, we need to create hand-drawn geometry, and then loading and filter image collection, then training a classifier, then classifying imagery. Then we can use it. What is the accuracy of this classification, and export as an image for your further process. So initially we have this is the ROI, just to visualize your area, and this is a imagery collection, and that's a composite, one of the algorithms to composite Landsat imagery. And then you can export your results in map sanction, and these are the some basically we have created lots of water, urban, forest based some sample points, and which we are showing in this area. We are showing. These are the hand-drawn sample points of our water, urban, and forest. Then import is an image feature collection. You can change your geometry as a feature of feature. Basically, what is the difference between a geometry and feature? Geometry is particular just a shape, and we can calculate using geometry an area or some buffer examples, etc. But in feature, you can also associate some attribute features with the geometry. It's it's a difference between in geometry you can use only shape, and in feature you can use shape parameter also, as well as you can use attribute parameter. So that's the feature collection. A collection just not features. It's just a group of features. So you can also for create a sample. We need to create initially geometry of particular samples. Then we need to create a convert geometry in a feature collection. Then add a property, a particular unique value also defined for different features. So then we need to merge all the features using merge function. Here I have merged water, urban, and forest using a merge function. Then we define this is a sample collection of trained your imagery as per training sample. This is a training sample. So, it's trained your imagery by using of this training sample with the using of this dictionary method. Then we create a smile random forest based classification, which is used with this name smile random forest and trained as per your bands. And after that we use this is the palette for water, urban, and forest, and then classify we have used. So this is just output of this, because it's a big script, so we need to just run and how to it will work. And it has used land use classification. In this blue color is shown as a water body. Here is a water body, and its green color is the vegetation, and some other area is just shown as some white color. So it's this classification. You can also calculate its area, and also you can be export in it in Google Drive and then export in your system. You can't able to export this result to your system because it has some limitation. And if you want to export your results in your system, you need to export firstly in your Google Drive. Then you can export from Google Drive to your local system. And you also need able using this Google Earth imagery. You can also work with a dam, watershed delineation, hydrological, climate change analysis, trend change analysis. Various types of functions is available to calculate your to measure your earth objects such as water, climate, tree, forest fire, such as, and some other examples also there. For example, I say histogram, day of the chart, export imagery. Yes. If you want to export your imagery in your system, then if you want to export your imagery in your system from Google Earth, imagery, you just going through this code. Just if you want to, this is a code to for particular image. If you just load this image using this variable and give the parameter to visualize this image as a true color, and give the geometry which areas you want to export, and then map.add layer to add this imagery in your map and center. Then we have given to a code for Google export imagery to drive. So initially it's export to drive, then you can download your imagery in your system. So in this dictionary, we have some arguments such as image, which image you have used. So we give a lens set. We need to download this imagery, and description is just optional. And what is the scale of this imagery? So we have now know about that. Its resolution is 30 meters, so you can use a scale as a 30 meter, and also you can give the geometry. There is a geometry is a region. This is used by this rectangle geometry based. So just run is the, so it has a geometry. These are the geometry, and these are the let's set image, but that's are bound with this imagery. And if you want to download it, you go to task. This is the task menu, and you go to task, and then you can find there is an image command to download in your imagery. Then you click on run, and it directly export to your Google Drive. Then you can download this image to your local system and process it. You can process this by using of ArcGIS or QGIS, etc. for this imagery for further process. So this is the basic functions to export your image to Drive. Similarly, if you want to use mosaicing is just very simple method using .mosaic functions. You can export, you can visualize your mosaic data. Various satellite imagery in particular image. So if you want to mosaic data, then you can use a particular this mosaic command, and it's an image collection ID, and it has a lot of imagery in this Nigeria bounded imagery, and then you can use a mosaic command. Mosaic command is used to mosaic all the image collection in particular one image. Then you can apply all the functions of imagery in this particular image. It's just a mosaic function. And that's all. So there is a very less time for understanding all the codes or all the concept of Google Earth imagery. So there's all there's some basic understanding of what is the user interface of Google Earth Engine and how it's working. Where is the code? We can put your code and we can run your. You can also share your Google Earth Engine code by via this Git link, and you can manage link. If you have any code, you can click on this. You can share your code with another person by using of this link. So it's very important to understand about and also you can generate your apps. And for example, there is a lot of apps is available. For example, climate engine, climate engine app. It's based on Google Earth Engine, and here are the some applications of which are developed in using a Google Earth Engine, and you can create your maps as well as your time series chart of climate data. It use various types of variable types such as climatology, hydrology, and forecast, climate forecast, hazards, etc. And also used remote sensing data. It has various types of satellite imagery and processed data, which is used for climate data for precipitation analysis and temperature analysis and land. There is various types of data is there available. So you can use a temperature, mean temperature, maximum temperature, and throughout the 1990 or before that, you can throughout of analysis how the trend is making in by using of this climate change. So this is a basic. You can create a imagery, and you can also create a time series of that. And now I'm stop my sharing of this and going through my presentation. And I'm sharing again my presentation is there. So I already described about how to add a shape file using this assets. This asset in this asset percent in you can add your shape file, own shape file, and further process your data as per your shape file. These are the some data types of satellite imagery processing, which is used for process image data, and this is already defined. Output of NDVI already defined. Time series analysis of defined. Classification is these are the some these are the steps of processing of classification steps. Firstly, create a hand drawing and then loading and filter image collections. Then create your filter place feature collections. Then merge training samples. Then apply sample in imagery. Then classification. And these are some apps based on Google Earth Engine already developed. For example, forest change analysis, which is used for and identify this. This is just used for the identify what is the changes of forest from 2000 to present, and it's developed in Google Earth Engine. Similarly, it's also developed in this. It's also I have explored in previous section. Climate engine, about climate engine, and it's an ocean time series investigator. It's used to and based on ocean surface temperature, which is used to identify the time series and trends of temperature of ocean temperature. And this is also another application which is used to just global population density in particular area. So you can see India and some China area has a dark spots is there, and there is a high density of population in available in Dhaka. In Bangladesh is also very high in population density. And these are some my work which I have created for identify what is the pattern of precipitations for Indian Himalayan region. It's a Indian Himalayan region, and it's a precipitation data based on a chill PS data. Its full form is climate hazards group infrared precipitation with station data. And if we can, it's a just a GIF image for yearly total rainfall from 2000 to 2001. And this map we have shown land surface temperature which is based on Moody's data, and it's also from same time duration for from 2000 to 2021. Moody's full form is a moderate resolution imaging spectrometer. It's also USGS and US based satellite data. It has a high temporal resolution per day. It's a visit time. Thank you. That's our presentation, and it's just a visualization of temperature changes from 1880 to 2021. It's developed by NASA. It's just a visualization of how to changes is temperatures occurred. Yes. If now if any have any questions, then you can ask me.
Okay, thank you, Maneesh sir and Abhimanyu sir for the hands-on session, which is very helpful for the faculties. Yes, faculties, any questions?
Thank you.
Participants, if any questions you can ask or you can write in the chat box.
Hello.
Yes, Sujata.
Yeah. Sir, can we create a raster maps like we can do? Raster maps can be created using this tool?
Pardon? Sorry, please ask us again.
Sir, can we create raster maps using this tool?
Yes, sir. We can create a raster map by using of different types of satellite data we can use in. For example, you can use a sentinel data, and if you can process as a classification, various classification method, then you can create a raster map data.
And the mask, sir, if you see as every images are different masks, right? So if I want to design a particular mask for some images, is it possible with this?
Masking.
Yes.
Yeah, you can use masking with you can provide some particular threshold values, then you can use a particular specific object analysis. You can for masking method also you can use.
Okay.
Yeah.
Thank you, sir.
Yes.
Any more questions?
One question is there. Say while doing we are doing a polygon on a particular map. Instead of it, why we don't use the already existing map of a city or a village map? So whether it is possible to select a particular map on that particular zone.
Yes. If you want to use your particular shape of or particular ROI, then you need to upload your own shape file. Then you can clip or you can process your raster data as per your ROI. As per your shapes. Hello. Yes.
Yes, by work, sir. I think you got the answer.
My question was whether a village map or a taluka map can be selected for a particular region. from on any
Basically,
particular.
yes. Basically, in Google Earth Engine, there is no last village data is available. But if you want to use, if you have your own zip file, you can upload your zip file via using assets menus, and you can use your own zip file data to particular clip satellite imagery or any satellite data. You can use own
Actually,
data. If
Manish, actually, let me answer this.
yes,
Actually, what is happening? Actually, this administration data is totally controlled by the Survey of India, and it is not into the public domain. So, if
yes, sir.
anybody, so if anybody wants to use that data, that person has to get the data from Survey of India in the digital format. It can be taken with some security measures, and till some level it is available, but not up to the village. Villages are available to the officials, to the government bodies only, and the cadastral maps also available to the government bodies. Secondly, if you want, there are some open platforms for vector data as well, where you can go even in GitHub also repository. You can find the data till block level of India, because there are a lot of research community people are there who are keep working and they are digitizing. So like it is digital platform, the people share also, so they there you can find till block level. So village also you can find, but that is not updated. Maybe that is some, I think around last updated is to 2011. Till you can get village data in open platforms. You can just search in GitHub and you can get the whole package of the state boundaries, district boundaries, and taluka block, and then village also. But that will be of old only. A new, if you want, you can just find out on the Survey of India website, and then you can take the data and just you can just rectify that open source data according to that. That's it. Your data is ready, and then you can upload, and then you can process your um, subject accordingly. I
Okay,
hope I
okay.
answered.
Yes, sir. Yes. I got it.
Any more questions? So I think there is no more questions. Archana ma'am?
Any questions from the faculty members? You can ask your questions in the chat box also.
Yes. Like if people will interact, it will be like good, because this is the platform everybody like focuses on everywhere. This is the like futuristic project by the Google, and this is just recent launch. So there are not much activity happening because it holds a limitation of programming. But if knows you knows the basics, it is limitless. You can create your applications, you can run
Yes.
your queries, building time series data, everything on one go, and you can have your own applications. You can develop your own applications. You can have a lot of things on that. So like if your area, you can ask from questions from your area also. Like
Thank you, Abhimanyu sir. Thank you, Manish sir, for such a
Thank you, man.
wonderful session.
Thank you, and thank you for this opportunity.
thank you,
Thank you to all.
thank you once again for inviting us on this platform. We would
Thank
like
you.
to make it for our long integration on this platform. Like in future also, we would like to meet again.